Good evening. This has been quite an eventful time. The new observatory at La Palma in the Canary Isles has been officially opened by the King of Spain, and European royal families were well represented. There's a view of the top of the 8,000-foot extinct volcano. There's the William Herschel Dome over to the right. Telescope's not there yet. There's the Swedish solar tower being officially unveiled. This is the Danish Carlsberg transit instrument, the most amazing device which actually takes transits by itself. Inside the dome, Professor Alec Boxenberg, Duke of Gloucester, over to the right-hand side. And there opening the dome of the great Isaac Newton telescope, transferred there from Herstmonceux and given a new mirror. Professor Boxenberg again inside the actual dome. Obviously, the transfer is a good thing because seeing conditions at La Palma are so much better than they are in England. You can see there the general view with the clouds actually below the volcano top. And I've no doubt we're going to have a great deal of very important information from there before very long. Also, on July the 2nd, the launching of the Giotto probe to Halley's Comet. It's a long journey. It's rendezvous with the comet on the night of March the 13th next year, and I'll have a great deal to say about it then. Also, on July the 12th, there's a very interesting launch of the Space Shuttle. It carries Space Lab 2, which is equipped with two important British experiments. One for studying the amount of helium gas in the sun's corona, and the other for studying X-ray sources in the Milky Way. And once again, I'll have more to say about that when we actually have the results. But it's some time, you know, since we did an actual look round the sky. And I thought it might be a good idea to do that now. Obviously, the moon's going to interfere in the first few days of the month. It's full on the 2nd. And of course, when the moon is full, or near full, it does drown most of the stars. That picture of the half moon was one that I took with an ordinary camera a few nights ago. You can see there the crater Clavius near the bottom of the picture. But although the moon does drown the fainter stars, it doesn't drown the bright planets. And there are several bright planets on view now. In particular, if you get up early, there is Venus in the morning sky, so brilliant you can't possibly mistake it. That was a sketch I made with my 15-inch reflector quite recently. It doesn't show a great deal, but then, of course, you never can see much on Venus because the planet's always cloud-laden and you can't see the surface at all. Nowadays, the phases are increasing to about half. But there's going to be something rather interesting on July the 15th, because Venus will then be very close to the lovely star cluster of the Hyades and the bright red star Aldebaran. That's a representation by Paul Doherty of what you will see if you get up early and the sky is clear. And I suggest it might be rather a good idea to take a photograph or two. The other really bright planet is Jupiter, and that's in the evening sky now, in the constellation of Capricornus, rather low down in the southeast after sunset. Telescopically, it shows its yellow, flattened disk with the cloud belts, great red spot not on view at the present moment. And you will also see the four bright moons, Io, Europa, Ganymede, and Callisto. They're easy to see with any small telescope, but of course they do appear only as tiny points of light. And it wasn't until the Voyager probes flew past them that we found out what they were really like. And just look at that picture of the outermost Galilean moon, which is called Callisto, an icy surface absolutely covered with craters. But I think the most amazing of all these satellites is the innermost one, which is Io, a brilliant red sulfur surface with violently active volcanoes. You can see there a volcanic plume to the upper left of the picture. We had absolutely no idea that Io was like that. One of the greatest surprises, I think, so far of the space age. The other bright planet on view now is Saturn in Libra. Again, quite easy to find, looking like a rather bright, slightly yellowish star in the southwest after sunset. And telescopically, the ring system is wide open. Again, that's a sketch I made quite recently, and you can see the rings well. But again, it wasn't until the Voyager programs that we really found out what they were like. And that's a magnificent Voyager picture. Look at the shadow of the ring on the globe, and the globe on the ring, the divisions in the rings, and also the rather muted belts, so much less conspicuous than Jupiter's. I think that Saturn is undoubtedly the loveliest object in the entire sky. The other two main planets, Mercury and Mars, are not on view at the moment. Toward the end of July, we shall start to see the first of the Perseid meteors. A meteor is a tiny body, usually smaller than a grain of sand, going around the sun in the same way that we do. When it dashes into the top part of the atmosphere, it sets up heat by friction and burns away in the streak of radiance that we call a shooting star. And there's a picture of a Perseid shooting star. The other trails are those of stars, because this obviously was a time exposure, and it was being made when the meteor was obliging enough to dash across the plate. There are many meteor showers. Meteors do tend to go around the sun in shoals, and every time we pass through a shoal of meteors, we see a shower of shooting stars. But of all these, the most reliable is that of the Perseids, so named because the meteors appear to come from a part in the sky noted by the constellation Perseus. They begin round about July the 27th, they reach their maximum on August the 12th, and they end about August the 17th. And this year, luckily, the maximum period is not going to be affected by the moon. So if you stare up into a dark, clear sky for a few minutes, any time round about the first 2 weeks in August, you'll be very unlucky not to see at least one Perseid meteor. We know, too, that meteors are associated with comets. As a comet moves along, it leaves a kind of dusty trail behind it. And when we pass through that trail, we get a shooting star shower. And many meteor showers are associated with known comets. Halley's Comet has 2 showers associated with it. We know that the Perseid shower is associated with a comet called Swift-Tuttle. And there's the only drawing I know of Swift-Tuttle. It couldn't be photographed because this was made in 1862, last time the comet was around, and in those days, photography hadn't got that far. We've not seen the comet since. We thought it had a period of about 120 years, and it should therefore have been seen again round about 1982, but it wasn't. So unless something has happened to the comet, which is not impossible, but not very likely, I think, either it's come and gone unseen, or else we've got the period wrong, and it may appear again in the future. Anyhow, we are still looking for it. Now let's come on to the stars themselves. On a really dark, clear night, if you're away from city lights, you will see the lovely band of the Milky Way stretching right across the sky. And you will be able to find out that it's made up of stars. But in fact, the Milky Way is not generally an area where stars are crowded together. You might think they're in danger of collision, but I can assure you they're not, because the Milky Way is a purely line-of-sight effect. Our star system, or galaxy, is made up of something like 100,000 million stars, arranged in the form that we've shown in this representation here, rather like a double convex lens, or, as I've often said rather unromantically, 2 fried eggs clapped together back to back. And the sun, with the Earth and the other planets, lies almost in the main plane, well away from the center, something like 30,000 light years. So if we look along the main plane of the system, that's left to right, or right to left in the picture here, we are seeing many stars almost in the same direction, and that causes the impression of the Milky Way. But if we could look at the Milky Way system from either up or down, you would see that it is in fact a rather loose spiral, and our sun lies close to the edge of one of the spiral arms. And there's nothing surprising about that, because we know of many other galaxies, millions of light years away, and many of those also are spirals. In the night sky at the moment, the view is dominated by what I've called the summer triangle. And that's a completely unofficial term. I introduced it in a Sky at Night program about 30 years ago, I think, and it seems to have come now into general use, even though it's totally unofficial. And it's made up of 3 bright stars in different constellations. And the first of these is Vega in Lyra the Lyre. And you can't mistake Vega. It's almost overhead during summer evenings, and it's very bright indeed, and it's also very blue, much the bluest of the really bright stars. It's also of special interest. It was studied in 1983 by IRAS, the infrared astronomical satellite, and found to be associated with cool material which may be either a planetary system or else a planetary system in the process of formation. That, of course, is a representation by Paul Doherty, but I just wonder, would Vega look like that from close range? Quite possibly it would. One day perhaps we'll find out. The second star in the unofficial summer triangle is Deneb in Cygnus the Swan. It doesn't look so bright as Vega, but in fact it's very much more luminous. It's a real cosmic searchlight, at least 60,000 times more powerful than our sun, and so far away that we see it now not as it is today, but as it used to be at the time of the Roman occupation, one of the most luminous stars we can see with the naked eye. Well, Cygnus is known officially as the Swan, unofficially as the Northern Cross, and I think you'll see why from that diagram there. But one of the stars of the cross, Albario, rather spoils the symmetry because it's fainter than the rest and further away from the center of the X. But to make up for that, Albario is a lovely coloured double star, visible with any small telescope, with a bright 3rd magnitude yellow primary and a vivid blue 5th magnitude companion, and any small telescope or good binoculars will show that. From close range, well, I wonder, would Alvario look like that? Quite possibly it would. The third member of the unofficial summer triangle is Altair in Aquila, the eagle. And you'll recognize that because they're the fainter star to either side. Altair looks rather brighter than Deneb, not so bright as Vega, but in fact it's one of our nearest neighbors, only about 16 light years away from us, and it's pure white. Another bright star, visible in the evenings now, is Antares in Scorpius, or Scorpio, the scorpion. You can't mistake it with Saturn because Saturn is much brighter and rather further over to the west. Antares is a huge red supergiant star, big enough to swallow up the entire path of the Earth round the sun. And it really is fiery red. The name even means the rival of Ares or Mars. And look out also for the outline of the scorpion itself, one of the most magnificent of all constellations, although, unfortunately, too far south to be well seen from here, and the sting barely rises at all. Following the scorpion round is Sagittarius, the archer. There's no distinctive shape and no outstanding star, although there are plenty of fairly bright ones. Some people say that Sagittarius gives the outline of a teapot. I never quite understood why. But it's notable because the Milky Way is very rich there, and we also have those magnificent star clouds which actually hide our view of the center of the galaxy. We can't see the real galactic nucleus. It lies beyond those star clouds, and we're not entirely sure what's there. There could even be a black hole. Now, the star clouds in Sagittarius are easily visible with the naked eye. But if you want to see them well, you do want some kind of optical aid. And I think I must digress for a moment here, because I've had so many people who have written to me recently and said, look, I haven't got much money to spend. I want to buy a telescope. What kind of telescope shall I buy? Well, all I can do is to give you my own views. If you want a proper astronomical telescope, I think you'll need a refractor, that's a lens telescope, with at least a 3-inch object glass, or a reflector, that's a mirror telescope, with at least a 6-inch mirror. And I'm afraid the cost rockets to over £200 straight away. You can get much smaller telescopes, shall we say refractors of 2 and 2.5 inch aperture and 3 and 4 inch reflectors, but frankly, I'm not a bit impressed. They don't collect enough light, they've got small fields of view, and they're very awkward and cumbersome to handle. And rather than spend a few tens of pounds on a small telescope, I would strongly recommend getting good binoculars, because binoculars have most of the advantages of a very small telescope, apart from sheer magnification, and they've got very few of the snags. So in my view, binoculars are far better than a small telescope. I'd recommend something like, shall we say, 7 by 50 binoculars. That's to say, a magnification of 7, and each objective 50 millimeters across. You can go up to a higher power, but once you get above a magnification of about 12, then the binoculars get rather heavy to hold. So I'd stick to something between 7 and 12 magnification. And if you do that, I think you'll find there's plenty to see. So I thought at this stage it'd be quite interesting to have a look around the night sky and see whether we can find some star clusters, open and globular. There are plenty of those around, and some are very well seen with binoculars, though of course you do need photographs taken with big telescopes to bring them out well. So let's begin at the Scorpion with Antares. And in the same binocular field with Antares, there's the open cluster Messier 4. And you can recognize that quite easily as a kind of a blob, and telescopically there are plenty of stars in it. But you'll recognize it quite easily with binoculars. But I think that even lovelier than Messier 4 is Messier 11. Messier, by the way, is the name of the French astronomer Messier, who catalogued these things way back in 1780. Now, M11 lies at the bottom of Aquila, actually in the little constellation of Scutum, the shield, and with the naked eye, it looks a bit like a broken-off part of the Milky Way. But with a telescope, you can see it really is a definite cluster, and it's been nicknamed the Wild Duck. That brightest star in it, by the way, is not a genuine cluster member. It just lies between the Wild Duck and ourselves. It really is a lovely sight. Now, those are open clusters. Messier 13, in the rather ill-defined constellation of Hercules, is quite different. You can just about see it with the naked eye, between the stars Zeta and Eta Hercules, as a faint misty patch. But binoculars show it well, and telescopes will bring out stars in it. In fact, so will good binoculars. And this is, in fact, a globular cluster, a huge symmetrical mass of at least 1 million stars. And I just wonder what we would see if we lived in a star in the middle of a globular cluster. The whole night sky would be ablaze, and there'd be no darkness at all. Another globular cluster you can find in the constellation of Pegasus, the flying horse, whose main stars make up a square. This is Messier 15. Again, you can see it with binoculars as a misty patch. You do need a telescope to bring out its details well. It is a nice globular, fully comparable with M13. The only two brighter globulars, I'm afraid, are in the far south of the sky. Now let's turn to something entirely different. M57, the ring nebula in Lyra, between Beta and Gamma Lyrae. This is what's called a planetary nebula, even though it certainly isn't a planet and is not truly a nebula. It is, in fact, an old star that's thrown off a shell of gas. When the Isaac Newton telescope on La Palma first became usable some time ago, we did a program from there, and we showed the ring nebula through various filters and gradually built up a combined picture of what it really does look like. That was the first time it had been done. Now, I think you'll agree the effect is rather spectacular. You can see the central star very clearly. In fact, you won't see that with a small telescope. What you will see is what looks rather like a tiny, shining bicycle tire. There are plenty of other planetaries. There's one in the little constellation of the Fox near Aquila. This is M27. Actually, the nearest naked eye star is Gamma in the little constellation of Sagittarius the Arrow. And this is known as the Dumbbell Nebula, for reasons I think you can see. That photograph was, of course, taken with a large telescope, but binoculars show the dumbbell very clearly indeed, and you'll even be able to make out its shape. There are plenty of planetaries in the sky, but those are some of the most important of them. There is another planetary nebula in the Great Bear, or Plough, and this is M97, not far away from Merak, the fainter of the two pointers to the pole star. It's known as the Owl Nebula. I think I must show you a picture of it. That was taken with a big telescope. It does look a bit like an owl, but frankly, I always find the Owl Nebula rather elusive, even with a telescope, because the surface brightness is low. But it's an interesting one anyway. And there are plenty of other clusters, both open and globular around, and plenty more nebulae as well. So binoculars do give you a wide scope. But there's something else interesting in the evening sky now as well. This is Comet Giacobini-Zinner. It's a periodical comet. We know exactly how it moves. At the moment, it's in the far north of the sky, and through July and August, it's going to track through the constellation of Cassiopeia, and about July the 31st, August the 1st, it's going to be near the two of the W stars in Cassiopeia, and as the magnitude will then be about 8, it should be an easy object, although I don't think it's going to have much of a tail. And there's a picture of it, taken on June the 16th by Brian Manning. There's the comet in the middle, and the stars are drawn out into short trails. Now, Giacobini-Zinner is important because it's going to be the target for an American space probe, International Comet Explorer, which will bypass it in the middle of September, and we hope send back interesting information. Obviously, you can't compare Giacobini-Zinner with the bright periodical comet Halley, which is now on its way back, but at least it's a good start. And Giacobini-Zinner should be well within the range of most amateur astronomers. And if you want the positions, I've actually given them in our latest newsletter. And that newsletter is now available. If you want it, then, as usual, send a stamped addressed envelope to this address, newsletter number 18, The Sky at Night, BBC TV, London, W12 8QT. But please, you must enclose a stamped addressed envelope, and please don't put any personal letters in with that, because they go to a different department. Anyway, I hope it'll interest you. And in the near future now, we should have some really fascinating information about how the Giotto probe is getting on as it goes on its long journey towards the rendezvous with Halley's Comet. So for the moment, good night.
That programme is repeated on BBC Two at 5:15 next Saturday.